Let us now talk about additional problems which involves a binomial divisor. Again, we are still on division of polynomials. Let me share to you right now the same material, or I mean the material on the same module, okay, which is on practice exercise C. In the previous video, you might want to check that out. We were able to discuss the processes on how do we divide polynomials with a binomial divisor. As for this video, still, we have binomial divisors here. But what makes these two items here different from the previous two items discussed in the previous video is that we are going to analyze this further because there might be additional things that we need to consider. Okay? Let's just start. The same as last time, we are going to place here our dividend, x squared minus 9. Sorry, let's make it better, 9. And you have here x plus 3 as the divisor as a whole. So we may automatically divide it the same price as we did before. But before that, let me just input just a important concept here. In the previous videos, we were able to talk about dividend, which has a complete decreasing order of the degree of the terms. To illustrate, one of our dividend in the previous video is x squared plus 13x plus 30. The degree of a term of each term is, as we already know, is the exponent of the literal coefficients. If there are many literal coefficients in a single term, we need to add the exponents. So checking the terms here, the degree of a term of the first term is the exponent of x, which is 2. For the second term, the degree of this term is the exponent of the variable x, which is 1. And since the third term has no literal coefficient here, we already assured that the degree of this term is actually 0. As you can see, the degree of the terms here are in decreasing order, 2, 1, and 0. But if we're going to look at our dividend here for number 1, we have a binomial here, binomial expression as a dividend. The degree of a term, the first term is 2. The degree of a term of the second term is actually 0. Noticeably, we don't have a term here which has a degree of a term equal to 1. That's what we lack here. The purpose of discussing this is actually there will be a great implication later on the processes that will be involved in number 1. I'm going to go back to that concept later as soon as we reach that concept that needs the application of degree of a term. As of the moment, let's just try to use the long division here, the process of the long division here. The first step is to divide. Divide the first term by the first term. So you have here x squared all over x, which is actually equal to x2 minus 1, x to the power of 1, or simply x. This is our first quotient. And we're going to place here the first quotient at the top. Okay. The next step is to multiply the first quotient to the terms of the divisor. And it should be to the both of x and 3. You might want to review the previous video because everything, the processes there were actually discussed already. So you have here the product or the process of multiplication. You have x plus 3. Use the distributive property. X times x is actually x squared. X times 3 is you have 3x, separator plus, so you have 3x. This is what you're going to place here, x squared plus 3x. The next step is to subtract. But again, as a reminder, when we subtract this, it should take as a whole. Okay. This is actually the area where the concept of the degree of a terms may be applied later because this is what will happen here. X squared minus x squared is actually that one. The next problem here is that there might be some problems that you will come out later on when you're just going to look at this vertical values here. Negative 9 plus 3x. Okay. Of course, you may actually, there are actually some of us, not all of us, okay? Some of us, or just few of us, who will tend to combine these two. and we'll say negative 9. I will apply here the negative sign, sir. So negative times positive will be, this will become negative 3x. Just, and then negative 9 minus 3, I have negative 12. And you simply copy x here. That is actually one of the misconceptions if you're just going to stick with this presentation. Why? Because some of us are still adding unlike terms. Take note that negative 9 has no literal coefficient and this has a literal coefficient x. So they are unlike terms. The other situation here is, of course, you're going to use the same process as before. You have x squared minus 9 minus the whole quantity of x squared plus 3x. And then you distribute that sign. This would become x squared, pardon, let me make it better, x squared minus 9. The positive x squared will become minus x squared. The positive 3x will become minus 3x. And then you will have x squared minus x squared, which is 0. And then you will have here negative 9 minus 3x. Most of us, not most of us again, rather, some of us, or even few of us, again, tend to combine this. Take note that negative 9 here is unlike or an unlike term to 3x and vice versa. So we cannot combine this. Therefore, negative 12x here is not the correct answer. And how do we remove that misconception now? Possible misconception. To remove the possible misconception of just combining these two because they are actually aligned vertically, we need to add here the missing term which has a degree of a term equal to 1. Okay, this is what happened in the previous video. Since everything is complete, so we could actually just subtract or add vertically automatically. But since for this dividend, we don't have a term with the degree of a term equal to 1, we need to place something here with that degree of a term so that we are going to remove this misconception. In short, let me just remove this. I'm going to move it here. Let me erase this one. And then I have moved minus 9 farther here so that there would be no misconception. So what we're going to do right now is we may add here a degree of a term, I mean a term with a degree of term equal to 1. And that is actually a term with x as the literal coefficient. So we are adding here a term with with the literal coefficient of x with the degree with the exponent of 1 to complete the degree of a term, descending order of the degree of a term here, 2, 1, and then 0. But if we're going to look at this dividend, it's not different from the given. The given only has x squared and minus 9. But now we are adding here an x. So we need to make sure that what we are adding here will complete the descending order of degree of a terms and at the same time will mean nothing. Again, we are going to add something here that means nothing so that it will not change the given dividend. And what should be placed here together with the literal coefficient of x? It should be the numerical coefficient of 0 because 0 and x now is separated by multiplication. So 0 times x will just be equal to 0. We are just basically adding 0. If we're going to add 0 to any expression, the expression will stand as itself. So the purpose here is we are adding here something with a degree of a term x that means nothing because it's just 0. And to look at that, uh, it has now the same little coefficients. Now we can just simply add vertically or subtract vertically with ease than just placing minus 9 here, and we'll create here this misconception. So again, we have, that's very obvious, that's incorrect. So we're going to do in this process here, this is actually the same when we're going to interchange here negative 3x and then minus 9. Again, we cannot combine this. So what happens here is negative 3x, right? And then you bring down here negative 9 for the fourth step, negative 9. Do not get me wrong. If some of you could just look at it automatically and get the correct answer without using the additional term that will mean nothing, It's okay. But of course, the purpose for this is just to apply and to make our solutions easier to be understood. Now that we have this, negative 3x, out from again, the plus sign becomes minus sign because it changes the sign here. And then we repeat the operation. So we are going to go back with the first term to the first term. So the division of the first term, negative 3x divided by x. You can just simply remove or cancel that x. We are left with negative 3. Again, the negative sign will be the separator, subtraction, and you have here 3. To check, again, this should take as a whole, multiply that to the both terms. That's the second product, negative 3 times x plus 3. Distribute, distribute. You have equal to negative 3x. Separator plus 3 times negative 3 is negative 9. So it is actually negative 3 minus 9. So you have here negative 3x minus 9. And then we subtract, and they should be taken as a whole. So when we subtract, this is the last difference, negative 3x minus 9 must be I mean minus the whole quantity of negative 3x minus 9. They must be taken as a whole. Distribute the sign. You will have here negative 3x minus 9. The negative 3x inside, because of the double negative property, will become plus 3x. And then negative times negative will become plus 9. Negative 3x plus 3x will become 0. Negative 9 plus 9 will also become 0. So the remainder is actually 0. Our final quotient is the quantity x minus 3. So again, see what happened in this example and compare it with the previous example in the previous video. There is the presence of a incomplete descending order of degree of a terms. Just by observing that, we could just remove any problems later. Of course, if you would like to check that, you multiply the whole quantity of the quotient to the divisor, and it should return the given dividend. Let's try. Checking. Your quotient is x minus 3, and your divisor is x plus 3. FOIL method, x times x for the first term, you have x squared. X plus times positive 3 is plus 3x. This one is, yeah, we have plus negative 3x. And finally, you have plus, again, I'm using the plus addition as a separator. So you have negative 9. So this becomes 0 because that's 3 plus negative 3. What is left now is x squared, and break this grouping symbol minus 9. See, our answer is actually the given dividend. We are now sure that the quotient when x squared minus 9 is divided by x plus 3 will result to x minus 3. This is for number 1. This is the challenge for number 1. Let's just continue to number 2. And before that, I believe I need more spaces here. Okay, just to emphasize the purpose of item number 2. Now, so for item number 2, we don't have actually concern with the decreasing order of degree of a term, because if you're going to check, this has 3, this has 2 degree of a term, 1 is 0. So all decreasing degree of a term for the dividend is already there, complete. So there's no need for us to place here any term that means nothing, or let's say 0x or 0x squared or anything like that. So we are just simply going to place the dividend here, x cubed minus 2x squared plus 2x, and you have minus 1. And place here the divisor x minus 1. Since we're not we are not anymore adding any term to complete the decreasing order of degree of a term, what makes number 2 different from the previous videos is that this needs three separate repetitive process. In the previous examples, and even including number one, we divided twice. Here, expect that we're going to do it three times. To show that, let's just start. So I'm going to separate this. So the first here is divide first term to first term. So first term to first term, you have x cubed divided by x. So you have x cubed minus 1, which will result to x squared. That's your first quotient. That's your first quotient here. The next process is to multiply that first quotient to both terms of the divisor. So you have x squared times x minus 1. Distribute that. You will have here x squared times x is x. If you would like to see the process, again, it looks like that. Separate by addition, x squared times negative 1. So your product here is x cubed because that's 2 plus 1. And plus, you have negative sign, you have minus x squared. This is your first product. Place it here, x cubed minus x squared. Next is to subtract as a whole. So you will have here your first difference, x cubed minus 2x squared minus the whole quantity x cubed minus x squared. And then distribute the sign. Okay, so repeat, just simply practice to repeat the processes so that will be get comfortable with it. I'm not saying that it will be easier, but you'll be more comfortable with it. So we have here positive times negative is negative x cubed. Negative times negative will become positive x squared. So x cubed minus x cubed, this 2 will be 0. Negative 2 plus 1 will become negative 1 x squared, which is simply negative x squared. That will do. This is your first difference here. That's the first cycle. The next cycle will follow after you will bring down here the next term to x. So the next cycle will cover these two, first term to first term. So you have it's negative x squared as it's given here over x. So negative 1 divided by 1 is negative 1. And then you have x 2 minus 1, which is actually negative x to the power of 1, or just simply negative x. That is your second quotient, and separate it using the sign negative x. Next is to get the second product, taking consideration that this operation is the sign of the second quotient. Sorry, multiply it here and here. So the second, okay, so you'll have negative x. Again, it takes the sign times the quantity x minus 1, which is our divisor. And then distribute that. So negative x times x. Again, let's use plus as a separator. Negative x times negative 1. So negative x times x is negative x squared. You have here 1 times x is x, and then you have two negative numbers, so simply plus x. That is what we're going to place here. Let's use, right, yes, it should be red. Negative x squared plus x. Then subtract as a whole. Your next difference will cover negative x squared plus 2x minus the quantity of negative x squared plus x. Um, Again, if you're going to do it on your own, simply take your time, study the signs, study the processes. No need to rush. So you have negative x squared plus 2x, and then distribute the sign here. Negative times negative becomes positive x squared. And then you have negative times positive, we have negative x. Negative x squared, that's just another color just to differentiate. Negative x squared plus x squared will become 0. Now you have 2x minus x, or 2 minus 1 is 1x, or simply x here. This is your second difference. In the previous examples, again, similar to number one of this video, we just ended up in the second cycle. But since we still have another term here, and very obvious, x can still be divided by this example here. So bring it down. Let's bring the term down. And then do the third cycle. We expect a third cycle because this is a multinomial by binomial. So x divided by x. X divided by x is just simply equal to 1. Positive 1, so you have here plus 1. Plus 1. And then you multiply this whole here and then here. For your second product, you have positive 1 times x minus 1. You don't need to distribute that. It's just simply positive 1. So it's just the expression as a whole, x minus 1. But if you would like to, you may 1 times x is x. 1 times negative 1 is still negative 1. And then subtract as a whole. Subtract x minus 1 minus the quantity x minus 1. This will become x minus 1. Distribute. You have minus x. Negative times negative will become plus 1. As you can see, x minus x is 0. Negative 1 plus 1 is also 0. This ends now your process because the result here is 0 and no more terms can be brought down. So after the 3 cycles, here is our quotient. X squared minus x plus 1. To check whether that answer is correct or not, simply multiply this quotient to the divisor, and it should return to the dividend for you to be sure that your quotient is correct or not. I'm going to leave that to you because this video will all is just focusing on the division of polynomials. So multiplication, you might want to use that as part of your review. Okay, again, this is what makes this last practice exercise for division of polynomials different from the previous video. Number one, we are adding here the presence of something that means nothing. And for number two, we have added additional cycle just to complete our process. It may take long, but of course you take your time. That should be the attitude of a mathematics student. So keep on practicing. See you later.